You've probably heard of the Feynman Technique. You take a concept that you want to learn, you write it out as if you're explaining it to a child, you find the gaps in your understanding, you go back to the source material and repeat until it's alright. It's elegant, it's simple. Richard Feynman was one of the greatest physicists who ever lived. A Nobel Prize winner, a safe cracker, a bongo player, and arguably one of the most gifted teachers of complex ideas in the 20th century. So, when someone actually packages his thinking into a 4-step learning framework and puts it on the internet, you naturally assume they got it right. They didn't. Not entirely. The Feynman technique, as it's taught in almost every productivity article, every study guide, every YouTube video, is actually missing a step, a critical step, a step that Feynman himself used almost unconsciously every single time he sat down to understand something. And without it, the technique is just note taking with extra steps. With it, it becomes something else entirely. My name is Chetan. Welcome to the First Principles Club, where we don't just learn ideas, we rebuild them from ground up. Today, we're going to dismantle one of the most popular learning frameworks on the internet, find what's actually inside it, and put it back together the right way. Stay with me as this is going to change how you study anything for the rest of your life. Before I show you what's missing, let's make sure we're building on the same foundation. Here's the Feynman technique as it's almost universally taught, and I want you to really absorb each step because the flaw is very subtle. Step 1. Choose a concept. You pick something you want to understand. Quantum mechanics, compound interest, how a vaccine works. Doesn't matter, you pick it. Step 2. Teach it to a child. You explain it out loud or on paper as if you're teaching a 12-year-old. No jargons, no hiding behind technical language. You're forced to actually understand it well enough to simplify it. Step 3. Identify the gaps. Here's where it gets useful. Wherever you stumble, wherever you reach for a word you can't quite find, wherever the explanation gets fuzzy, there's a gap. That's a place where you have an illusion of knowledge instead of knowledge. Step 4. Review and simplify. You go back to the source material, plug the gaps and repeat the process. Each cycle, your understanding deepens. Each cycle, your explanation gets cleaner. Now, on paper, this is actually brilliant. It targets what cognitive scientists call the illusion of explanatory depth, the very human tendency to think we understand something better than we actually do. Research from psychologists Leonard Ross Belton and Franklin Keel found that when people are asked to explain everyday objects like how a toilet flush mechanism works, their confidence collapses almost immediately. We think we know things we're merely being exposed to. The Feynman technique is designed to expose that gap. So, what's really the problem? The technique, as taught, treats understanding as the final destination, as if the point of learning is to be able to explain one thing clearly. But Feynman never thought of it this way. When Feynman learned something, there was always a deeper question underneath the what and the how, a question that most learning frameworks never ever ask. And without it, your understanding stays inert, accurate but lifeless, correct but disconnected. He calls it, though not in many words, finding the question behind the question. Let me show you what exactly I mean. Richard Feynman wasn't just a physicist, he was a philosopher of curiosity. He wrote about this extensively in his memoirs, in his letters, in interviews after interviews. Here's something he said that most people skim past. I don't know what's the matter with people. They don't learn by understanding. They learn by some other way, by rot or by habit. They think they understand it, but they get stuck. Read that carefully. He's not just criticizing memorization, he's identifying a specific failure mode, thinking you understand something because you can repeat it. The Feynman technique, as most people practice it, stops at one question. Can you explain it simply? That's the test it applies, and like it should. But Feynman applied a second test, a arguably harder test. Why does this have to be true? Here's the complete Feynman technique. 5 steps, not 4. Step 1. Choose a concept. Step 2a. Teach it to a child. Step 2b. The missing step. Challenge the foundation. Step 3. Identify the gaps. Step 4. Review, simplify, repeat. Step 2b, between the simplification and the gap finding, Feynman always asked a question most people never get to. Does this have to work this way? And if so, why? Not just what is this or how does this work, but does it have to? This is the question that separates someone from somebody who knows physics to someone who thinks in physics. It's the question that separates a person who can describe a business model from someone who can build a new one. It is literally first principles thinking. Now, let me show you what this looks like in a real world. 3 examples, 3 completely different domains. Same question, completely different depth of understanding unlocked every single time. Feynman, teaching introductory physics at Caltech in the 1960s, would regularly stop mid-lecture and ask his students something that made them deeply uncomfortable. Not what is an electron, but why do we believe electrons exist? Not how does this equation work, but what would we have to observe for this equation to be wrong? He was teaching them to challenge the foundation. Not destructively, not clinically, but with genuine curiosity about whether the map actually matches the territory. And every time a student could answer that question, Feynman knew they actually understood not just the shape of the idea, the bones of it. Let's say you're using Feynman technique to understand compound interest. You go through the standard steps, you simplify it, you write it out, you find the gaps. By step 4, you can explain compound interest clearly to a teenager. Most people stop there. They've learned compound interest, but have they? Here's the step 2b that they are actually missing. Does compound interest have to work this way? Why does reinvesting returns generate exponential growth rather than linear growth? Now, you're forced to think about the mathematical structure underneath the concept, about why multiplication scales different than addition, about what a percentage usually represents at its core. You've stopped learning the label and started learning the logic. That's the difference, and it shows up viscerously when you try to apply it to real life knowledge. Same technique, different domain. You're reading about network effects, the idea that platforms become more valuable as people start to use them. Standard Feynman, you simplify it. Facebook becomes more valuable when more people actually join because there are more people to connect with. It's very simple, right? Clean and simple. Step 2b. Does this have to be true for all platforms? What would have to change for network effects to stop working? When do they reverse? When does more users actually make a platform less valuable? Now you're thinking about congestion effects, about how Twitter became hostile at scale, about why niche networks can outcompete general ones, about the conditions under the Metcalfe's law breakdown. You've gone from definition to a mental model you can actually deploy almost immediately. That's what Feynman was doing every time with everything. He didn't just want to understand the world, he wanted to understand why the world couldn't otherwise. And the moment you ask that question, the moment you genuinely wrestle with it, your understanding doesn't just deepen, it roots itself into your thinking absolutely permanently. Think about understanding as levels on ladder. Most people climb to the middle rung, explanation. They can describe the thing that feels like understanding, and it is partial understanding. But Feynman always climbed to the top rung, the place where you don't just know how something works, you know why it couldn't work any other way. The top rung is where First Principle Club lives, and the 5-step protocol is exactly how you get there. Here's your updated protocol. Next time you sit down to learn anything, a concept, a book, a skill, run it through this 5-step sequence. Step 1. Write the concept at the top of a blank page. Step 2a. Explain it in your own words. Simplify as if you're explaining it to somebody with no background in that subject. Step 2b. Ask, does this have to work this way? Write down your answers. Even if it's I have no idea, especially if it's that honestly is the point. Step 3. Find the exact places where your explanation faltered or your step 2b answer felt empty. Those are your real gaps. Step 4. Return to the source material specifically to answer step 2b. Not just to fill it in what, but to understand the why. One final addition. Keep what I call a Feynman Journal, a notebook. It can be physical or digital. Title it something like Things I Actually Understand. Every concept you run through this 5-step process goes in there. It becomes a library of ideas you genuinely own, not just recognize. The difference between a library you own and a museum you visited is the difference between wisdom and trivia. Every time you stop at standard 4 steps, you're adding to the museum. Every time you push along to that step 2b, you're actually building the library. The choice is available to you every single time you sit down to learn anything. Here's what I want you to walk away with today. The Feynman technique is genuinely one of the most powerful learning tools ever articulated. I'm not here to tear it down, I'm here to complete it. Because Feynman himself wasn't just a good learner, he was a different kind of a learner. And the different wasn't in how hard he worked or how long he studied. It was in the question he never stopped asking. Why does this have to be true? That question is the heartbeat of first principles thinking. It's the question that every great scientist, every great builder, every great mind in history has used, often using it without being able to actually name it, to go from understanding something to seeing through it. You now have both halves of the technique. What you do with it is completely up to you. But my honest advice, pick one concept you think you already understand. Run it through the 5 steps, especially step 2b, and see what you find. I'd be willing to bet you will actually be surprised. Now, I want to hear from you in the comment section. What's one concept you thought you understood until you tried to explain it? Drop it below. I read every single comment in the first 48 hours, and the best answers from the community consistently become the seeds for the future videos. So you're not just commenting, you're co-creating what comes next. If this kind of thinking is what you're after, if you want a channel that doesn't just hand you frameworks but actually rebuilds ideas from ground up, then First Principles Club is exactly where you should be. Hit the subscribe button, turn on the notification. Every single video that we actually make starts from one question and ends with a model that you can almost immediately deploy. And if you want to go deeper right now, the next video is on inversion thinking, the mental model that Feynman, Charlie Munger and Jeff Bezos all use to solve problems that everyone else gets wrong. It's the single most underrated thinking tool I've personally ever come across. I'll put it right here. I'll see you there. Till then, good luck building.